Dr. Moore-Ede, it's so exciting to have you here today. We're going to be talking about one of my favorite topics as of late. You wrote a book called The Late Doctor, and I have it right here next to me. And there are just so many fascinating things in there and discoveries that I've made over the last several months that I'm excited to talk with you about. And you've been around this area of circadian health for a really long time. So why don't we start out by you just giving us a brief synopsis of your history and how you got so invested and interested in circadian health?
Well, it goes back, quite a number of years. But when I graduated out of medical school and was going into a surgical rotationship, resident, I found myself working in those days and still today these 36-hour long shifts on duty, nonstop, 6 hours, off for 12, back in. And that exhausting schedule was one thing that got me interested in sleep. But I also was aware that it was under bright fluorescent lights, no LEDs in these, but the bright. And anyway, what happened, it really screwed up my sleep, my health, well-being, my mood. I was nodding off in the operating room, not being able to, keep awake at all times. And I found myself not, writing prescriptions I couldn't make. So all those things led me to say, look, this is really something here. There's something to this because there are clearly rhythms and patterns. And so I took a detour out of surgery and went down to Harvard Medical School to do a PhD on what was a brand new area. Before I entered medical school, there were only 3 papers published the year I did between circadian rhythms and now, of course. And so it was a very new field. In fact, I was warned at that time by a senior professor at MIT. He said, don't go in that field, Martin. That's just a dead end. No science there. It's not a career for a young man. I'm so glad I ignored him.
Yeah, I am too.
So anyway, but the point is, I then delved into the mechanism we discovered, after my PhD. I then joined the Harvard faculty, this brand new science, assembled a group of brilliant postdocs and graduate students. And we're able to define, first of all, we discovered where the clock was in the human brain. It had been found in mice and rats, but not in humans. And then the circadian clock, that's the clock that controls the near 24-hour cycle, sleep and wake and hormones, temperature. And then we were able to show that it actually was synchronized by light. The feeling at that time, the general knowledge was social interaction synchronized, but in fact, it's synchronized by light, as with all that. And from there, we were able to show how much disruption occurred. All these bodies that failed when you got into what's called circadian disrupted, not only the master clock in the brain, but also all the other clocks throughout the body. And there, as every tissue of the body, every cell, most cells will have clocks in them. And when they get order with it in disarray or disruption, then all sorts of metabolic. And so that was a major area. When I then took a detour, in a sense, out of the lab into practical application, circadian rhythms, formed a company called Circadian, which now has offices around the world and deals with businesses that run 24, you can imagine, runs around the clock, from railroads to airlines to nuclear power plants to offshore oil wells, everything else that runs around the. And as I was doing that, the papers started coming out about 20 years ago now, were saying, look, there is this percent increase in cancer, breast cancer, in women, particularly young women, premenopause, who've been exposed to light when working night shift. The first thought was, well, this would be something about the shift work itself, the environmental exposures people who work in it have. But in fact, as we've gone on, we've realized this is actually light, the exposure to light at night. So that was the first major discoveries. And that in turn led the World Health Organization in 2007 to declare that light at night and shift work was carcinogen with breast cancer. So that's 2007. So that's about a little over 20 years ago. And at the same time, some key discoveries started coming out to suggest it was actually the blue part of the problem. One of the things was I was talking to these Fortune 500 companies. We had half the Fortune 500 at that time. And they were saying, Martin, what are we going to do? We can't deal with this cancer risk, but we can't switch off the lights. We can't not hire women, right? You can't deny women the ability to earn well-paid. We can't stop our business. We can't abandon the night shift. What do we do about it? And So, and that was really a quandary until really we really started to understand the blue part of it. And we realized that if we could isolate the exact blue that was causing the problem, we would have a solution. We could actually build lights that were attractive and usable, but had no blue in them. So that formed a research center, Circadian Light Research Center in Boston, which was funding for health and multiple other places. And we're able to, through a series of studies, identify in humans who were working nights, looking around, we were able to identify a rather narrow band blue light. It turned out sky blue. There are a lot of different blues in the lights. So the light spectrum goes all the way from violet at one end to deep red at the in the blue part of which goes from about 400 nanometers. There's a narrow band centered around about 480 blue light. It's not the violet blue, not the royal blue colors. It's called blue. That actually is the key to circadian rhythm. I mean, one of the things it does for there's receptors in our eyes detect this sky blue color, a melanopsin in our eyes, melanopsin blue light. In turn, that was enabling us to, once we understood that, and once we understood that the color we had control, we could then go next you start to build light. Now the key is it's not blue. Blue is good during the day. You want a sky blue, synchronizes, but in the evening hours and nighttime, seeing that blue in the light highly, because it tells the body it's not it's still daytime, and that signal mediated by hormones like melatonin really is the key. So basically, once we understood that, story short, we were able to develop LED lights that could solve the problem. We were able to show we could reverse all the metabolic problem occurred with blue light, and we could then know that we've got a solution. That's the full cycle. And really, I've written this book, The Light Doctor, to tell that story, but also help people understand how important it is to understand this and the role of this sky blue color in determining our health and when you need to see it and when you don't, but also to sort of give really a push to all of us to start asking. We are just bathed these days, very blue rich LEDs sting at us night and day. That's a real problem. And the LEDs are there for a reason. They're energy efficient, seen as measured as being energy, but they're causing also. So the bottom line is there's something, it's a problem, it's an environmental pollutant, something very effective solution for it. So we don't have to have it. And now it's a job of education. So that's it. And of course, talking to you is part of that education. So a long story, but that's in a nutshell, the path I've.
Wow, it's a great story and huge, huge discoveries. And most people that I talk to have no idea the implications of blue light at the wrong time. Like you said, it's not like we need to shut down all blue light and get rid of all of our electronics. It's just knowing when to block it, when, how it's working with all of the body systems. So yeah, so you and your team discovered the SCN, or the suprachiasmatic nucleus. I hope I'm saying it right. In the hypothalamus. And what year was that again? Tell us a little bit about that, because and I wanted to ask you too, is that like well accepted in the medical establishment? Because sometimes these discoveries are made and people are just like, maybe, they're not accepting of them. So tell us a little bit about that discovery.
Well, that goes back into the 1980s. So that's been around for a while. And yes, it's well-established science. Basically, the suprachiasmatic, by the way, my favorite typo, someone was typing up a manuscript and labeled it as the supercharismatic.
Very charismatic.
Yeah.
A good personality.
But now, let's not confuse people. It's the supra with an A. Chiasmatic, which is where it's just above where the optic nerve is crossover the optic chiasm. That's why it's called and it's a pinhead-sized group of cells in the brain. It, as I say, its own direct pathway from the eyes, a non-visual pathway. In other words, most of what we do with our eyes is see images, pictures, colors, everything else. It's a vision which roots its way back to the back of our head, to the occipital cortex. See things, right? We visualize. But this is a pathway that's non-visual. And so it triggers all these automatic responses. This pathway goes directly from those blue detector cells, the melanopsin, the long name for IPCs. Those are IPCs in the eye. Melatonin picks up this blue, sends a signal to the clock, in turn sending out many signals and controlling internal rhythm of the body. So discover that, yes, it was an interesting story because here's something that was first traced back in rats, and they were able to pathways that's possible and knock it out with needs, and then the animal become totally arrhythmic. In other words, no circadian rhythms, just randomly day and night. So, but it wasn't there according to the humans. Now, you understand when neurologists at the brain and neuro at the brain, they use an atlas of the brain, which is a series of like an atlas of slices through the brain systematically. And that sounds fine. You think, well, what we discovered, and one of my postdocs discovered, he found that in fact, they only in these atlas saved, so they made 50 slices and then threw the 49 away and then showed a pick too many slices, very thin.
Yeah.
Just take too many pages to the atlas. So if you've got a small little cluster of cells, you're going to miss it, and indeed that. So it was never recognized. And so he went back and looked at all the 49 slices between the slices that were, and lo and behold, there was this nucleus in the same place it is in animals and rats, and we were able to identify it. And it just hadn't been recognized. I think at the time we found randomly, depending on where that slice fell, it had been discovered and then not seen again. It was given, I think, 10 different names to show the confusion.
Yeah.
10 people named it 10 different things when they happened to randomly find it. But we were able to identify it. And so that was about 19 when we,
Okay.
and of course, since then, there's a huge amount of work on the nucleus and how it works and grow the.
Yeah.
But that's the story how we found that. And the other story about light was that, as I say, we were able to build an apartment with no windows and no clock where people could live in, and then really examine as people lived there for the time what signal there, discovered that it was again a very powerful. And so those are two key findings, because that really set the field. It said, yes, humans are like other animals. We all have these clocks in the brain. We all have these multiple, we all synchronize. So that's.
Yeah, amazing how just a little tiny cluster of cells can basically dictate our entire existence throughout the day. And as you said,
your cat there in a quarter,
my dog, yeah.
also has a suprachiasmatic nucleus. They're a bit more random in terms of their sleeping cats.
Yeah, although she likes, I got a pitch black room and she likes to lay right next to my bed, and that's where she sleeps. So it was a dog. I know she looks kind of.
Was that a dog or cat?
Yeah, she's a dog. I know she's far back.
I do sincerely apologize.
No, that's okay. She's actually a big dog, so but she's kind of far back in the room, so she probably looked like a cat coming in. But yeah, so she's got more established sleep wake patterns for sure. But yeah, how profound that little cluster of cells can make such a, just basically run our whole existence. And as you said, there's tons of millions of timekeepers throughout the body, and each organ has its own timekeeper. And as I was reading in your book, some of them, like, let's talk about travel a little bit and jet lag and why that happens, because I think that's really interesting. And we haven't really touched on that on the podcast at all. And it all comes down to that circadian clock. But if you are flying and crossing many time zones very quickly, it takes a while for some of those timekeepers to catch up, versus if you're traveling even by car or by as the example in your book was a ship, it's a lot easier to adjust. But do you have any tips as to how to travel well and feel better if you're crossing a lot of time zones, and kind of try to not have the jet lag once you get to your destination?
Well, first of all, jet lag occurs because literally there is a lag in catching up. And the most fundamental part of that is so-called, because some of the sleep adjusts more rapidly than, for example, kidneys do or liver do. So for a while there, as they're all trying to catch up with each other, things are in disarray. And that's why you got the rather lousy feeling of malaise to the body you're out of. So the short answer to jet lag is, how long are you going to be there? So if you're just going to go there for a quick trip, and a day, two in Europe, it's really not worth trying to do the you want to try as much as possible to do something where you have some sleep on your regular home time. Try to control your schedule so you can and try to adjust without really. So that's one of the first things. I mean, when I fly to London, for example, I'm a natural early morning type, so I get up at 5 o'clock. We are people; their clocks are set earlier than others. I get up 5. Other people, of course, get at 9 sometimes. And that's their natural. Well, for me, when I go to Europe or go to London, there's only 5 time zones. And as a result, I become equivalent to a late night person there. So I adopt that. So I sleep in late, all the time. And then I'm actually, can enjoy going out for dinner in the evenings after the theater, something an early morning type like would never
Yeah.
consider, right? You can just adjust your. So that's what you're going for. If you're going for a longer period of time, then you can, first of all, it matters when you travel. For example, if you are, again, taking that example, flying to Europe, flying to Paris, it's so much easier if you fly during the daytime, because then what you're doing, you can stay up late, you arrive, and adjust, and you're not going in. Of course, when you fly overnight, you're sleep deprived. You don't get really great sleep on a plane. Nobody does. It's truncated into short. And then you arrive at this, gasp time in the morning. So those times arrive, let's say they come in at 7 a.m. and you're into London, 7 a.m. That's 2 o'clock in the morning.
Mm-hmm.
Now, one of the things to watch there is to understand how the light in the evening hours shift your clock. Light falling on your eyes in morning hours, early morning, eastward. So now, if I arrive at 2 o'clock in the morning body time, I'm at the point where I actually might be still in that mode of my clock, because it's still the middle of my biological night. In other words, I'm shifting myself to California time when I'm arriving in London. So that's one of the things to watch. So basically, really protect from light early when you arrive. Go out and have lunch outside in the sunshine at noon. Now you're getting light, scheduled to your, my time is Boston, more scheduled. Yes, think about when you're exposed to, and then when you are,
Sure.
all the other general.
Right. Well, let's go back to blue light. And you spoke a little bit about cancer and how blue light has been found to increase breast cancer. And sometimes on the podcast, we have to shy away from this whole topic, but this is well established. And like you said, in 2007, blue light was, established as a known carcinogen or probable carcinogen. So let's talk a little bit about how it increases cancer risk and how it increases the risk for metabolic insufficiencies and metabolic disease as well.
Yes, absolutely. Now, so why do we care about blue light exposure? Because of this very disruption. One key thing it does is melatonin. Now, melatonin is the hormone normally released by your pineal. The darkness, it's not a sleep hormone, actually, the hormone that is triggered by the absence of light, allowed to come out, peak around 2 o'clock in the morning, and then it disappears but it's the darkness that sends the signal to the body to go into repair. But melatonin also has a very important, it is actually cancer. So we all have a tendency towards throwing off the odd mutated. Melatonin helps suppress. So when you suppress melatonin, you are depressing the body's ability to inhibit cancers growing in your body. And so that's one part of it. And then, of course, the disruption to the body more likely. So that's one of the key things. And then other diseases, like obesity, diabetes, the blue light, blue content. We're not talking about light that looks harmless, but it's got a lot of blue in it. See it with your eyes, but that blue component that's hidden in the spectrum of light, you'd only see in a rainbow. That blue spectrum the problem. So what it does, that blue part, is it actually hungry. People who are working in lights that are rich in blue, like eat, we find people snacking. We find that blue light also cause what's called insulin resistance. So we can put perfectly healthy people, no diabetic, their blood sugar or anything, put them in a room with regular LEDs on at night, and we can make them pre-diabetic by the morning. So there's a classic determining what diabetes, the glucose tolerance. You drink a bottle of sugar water, and this takes every half hour or so a blood sample, and and you measure the blood, glucose rises, insulin rises, they go up, back down again. If you're diabetic, the levels rise higher, both of insulin and glucose, and it stay up because the insulin. Well, lo and behold, just regular healthy people put in a room full of LED lights for a night will actually become pre-diabetic. They will, glucose tolerance that people would get flagged as. So it shows how it can act. Now, something like breast cancer, that may take us more to. So that's not what you see immediately. But of course, the longer you work, night shifts and also it's not night shift. We should also, it's also the danger of using the lights in the bedroom. 40-50% of the population actually lights on in the bedroom. And so we know that people who do that, they're not working, they're just in the bedroom, also have cancer also in men from colorectal. And what we now know is all those cancers are climbing. So breast cancer rates are 4%. That if there are 100 people with breast cancer, new cases, so the actual accelerating, and people are scratching their heads and saying why. And why, I believe there's a very obvious reason. It's because of the impact of these LED lights, blue rich, it's 9% store, and they're causing this problem. And it's so addressable. Now, you might say, how do you know? Well, number one, women who've never seen electric light rarely get. So who are those women? Well, women before the advent, in other words, before Thomas Edison, before the blue rich fluorescent in the 1960s. Breast cancer is now the most. Secondly, women who are living in parts of the world with no electrification. Actually, millions of still don't have electricity, so they have very low. And thirdly, and most interesting, women who are blind. Now, they've had all the other exposure, everything else, but they just be blind. So this evidence now is, we've seen breast cancer rise fivefold. There's at least a fivefold between women. It's a bit like lung cancer, with the smoking. With smoking, people get lung cancer with non-smokers. My brother last year, a couple of years ago, lung cancer, never smoked, but 80% are due to people. So there is a baseline. Similarly with this breast cancer, women who've never seen electric, women who have bright, electrified countries of the world, that's in Europe, those kind of more women. So there's more, 4, 5, 6-fold greater if you're in an environment where there's a lot highly electrified than if you're in a rural city floodlight. So this is such an obvious contributor, and yet people really triggered on. Yet people are saying water is a big contributor. I'm not saying it's the only cause, but it sure is a major, and it sure is one that is addressable, solvable, because we produce a lot that have no blue in them.
Right.
Now, you might say, well, people always have candle-lit wood fires. Absolutely no. There's virtually no blue in candlelight. Virtually no blue in wood fire.
Right.
It's all the Edison invented the light bulb. He mimicked candles, so it's those incandescent bulbs that now you can't get banned. At relatively low levels. But now we're faced with incandescents are banned from really misguided policies. And
Right.
what's happened is more blue content, and even if they're soft white. So we really are poisoning ourselves. And there are a lot of things that are pollutants, PFAS chemicals, there's forever asbestos, all these things are causing problems. Very, very hard to get rid of some. But here it's so simple.
Right. So is it mainly the nighttime blue light that is affecting the metabolism and increasing cancer rates because of the melatonin suppression, and not so much the blue light, artificial blue light during the day? Or is that also having an effect on us? And lack of sunlight, are those also coming into play?
Well, first of all, sunlight is rich in blue, and that's very good, very healthy. People who get outside in sunlight, and I take a walk every morning purposely, for half an hour, to get bright exposure, bright rays. People have much lower rates of cancer, heart disease, and live longer who do that. So you want to see light, particularly in the morning. But it's your question. You want to see blue in the light during the daytime. Where it becomes disruptive is so if you think of it between dusk and dawn, between sunset and sunrise, that's when you're vulnerable to and it's not a question of avoiding it. So if you're wearing blue blocking glasses, which number one, make sure those glasses are blocking the right blue, because a ton of them are totally wrong part of the blue spectrum. There's really a bit of a scam going on with these, quite frankly. These blue blocking glasses are removing the violet blue part of the spectrum. They're not doing anything in the evening. So these are glasses, you're going to need glasses yellow, orange, and you can do that. So that will remove the blue. So you can change the light bulb, wear glass, but you also think the screens and your cell phone, they're all part of the problem. So that's why, being really aware of that and minimize. And lastly, of course, sleeping in the dark. So the rules of life are pretty simple. Control your light exposure. So that's okay. You can do it in your light bulbs available to do that now. But what about spaces you don't control? We're all in our workplace, the library, the hospital, wherever you are. And there is where we've got to really campaign, and we've got a campaign for healthy lighting. You can join it at circadianlight.org, one of our websites there. But basically, to really campaign to have those public spaces also be aware of we've got to do a whole thing in a way. We're taking it so much for granted. It's so easy. It's on a wall. It is so people don't even think about what's lighting them up. Unless you're in the lighting business, by the way, you never look at, you're not aware of it. That's
Absolutely. So going back to the sleeping in a dark room, there are many, and a lot of elderly people, especially, who are sleeping with lights on. Is the light penetrating the eyelids even though you're sleeping, or is it being absorbed by the skin, or how is it disruptive even if you're sleeping? Like it seems obvious if you're working under bright lights, let's say you're in a medical establishment and you're working under the fluorescent lights, but how is it disrupting your sleep even if you're asleep and you just have like a lamp on in the room?
Yeah, it's coming through the eyelids. The eyelids do not block the brightness. I mean, obviously they do reduce the intensity. Still, the light is coming in through the eyes, and we're very sensitive to low levels.
Mhm.
So, so it's not, no, it's not through the skin. And besides, most people in bed have got the bedclothes covered. Their skin is actually covered. No,
Yeah.
this now you can prevent it by sleeping with blindfold, right? So if you're in a room and you can't sleeping in a room where you can't control the lights in an airplane, then sleeping with a blindfold can do the preventing the light getting to your eyes, and your eyelids themselves are not, then they're not blackout.
Right. Right. Good to know. Cause I always wonder that. I'm like, well, if your eyes are closed, how is it? And I know that your skin can absorb the blue light, even like if you're watching TV or, and that can have an
Yeah.
effect
Well, I
too.
think, yes. I mean, the amount of absorption from the spectrum, it varies very much. So actually, you don't absorb very much blue light. It doesn't go very, very small distance. It's enough blue light, by the way, to convert. If you had a baby that's jaundiced, a newborn baby that's jaundiced, they put blue lights on because that actually breaks up circulating bilirubin, actually, cures the jaundice born baby. So but that's skin, the blood flowing through doesn't go very.
Okay.
But the far end of the other end of this from red penetrates quite deeply
Yeah.
into it. And that's why red is actually used for photobiomodulation. It's used very to heal scars faster. We're learning a whole lot the role of infrared is in terms of lights. Edison's light bulb, a lot of infrared light, all that disappeared with the invention of the LEDs. We're now wondering what there because the sun has got a lot of it. So, when you're going out in sunlight during the day, you're getting the ultraviolet, visible light, and the infrared. All of that together is clearly. So we're just really starting to learn what each part of that does. Fascinating, each part of this different role, different effect. The green part of that is actually reversing migraine, dealing with soothing people, calming. All sorts of interesting with the green light coming through your eyes. So we're learning about each of those different parts of the lights indoors. Very poor
Yes.
of light. They're not natural light. It's far dimmer than light. We're actually twilight level. So and that's so as much the problem is the absence of exposure to daylight and sunlight. Our ancestors in the old days spent most of their days outdoors or being exposed to daylight. So the two problems is the lack of sunlight, adverse of too much blue light in the evening hours that are really causing huge disruption, deterioration of our health. So we do all these wonderful things for public health and modern medicine and everything else. But, if you don't causal, you're just all sorts of obesity, breast and prostate, psychiatric illnesses, all have been linked.
Yeah. I think I've heard that the average American spends about 7 minutes outside per day. And a lot of it is walking into work and walking out of work. So I spend as much time as I possibly can outside, and I go, my environment, it gets really cold in the winter, but I dress for it. I go outside and I am actually this winter, this is the first time I'm going into winter knowing all of this circadian stuff. And it's, I've lived in Wisconsin my whole life, but I always, there's always just that dread factor where, oh, we have this long, cold winter. But now I'm like, okay, now I can embrace the dark and produce more melatonin and use that to my advantage and embrace the cold and take advantage of the longer days and maybe be in ketosis more and do a little bit more fasting here and there because I don't have all of the food available naturally that I do during the summertime. So this is the first time I'm like, okay, I can do this. There's some benefit to me.
Yeah, well, it helps that this is actually the main effect, right? Because you can
Yeah.
bundle up everything else, and
Right.
you can wear all your clothing and everything else. This is not people sometimes think that people who are so-called sunset daylight, they must be running around in bathing suits. No, you don't have to run around in bathing suits. People don't. You can get all the effects fully clothed. You can enjoy this fully clothed.
Yeah, it's particularly UVA. I'd love to talk about the UVA time of the day, which is 10 to 30 degrees when the sun is in the sky. But you alluded to the reduction of mental health issues and anxiety and depression when you're outside more often. So and UVA, correct me if I'm wrong, you can just get it through the eyes. That does not, I know the UVB to generate vitamin D, that needs to be on the skin, but can we talk about UVA a little bit and how that's coming in through the eyes and what that is? That's a really magical time of the day to get outside, and so many things happening that are coming through the eyes and setting off those triggers.
Well, I think it's that spectrum that's coming in the early morning hours, really, really, and it also you avoid, the downside of being too exposed to too much sun, as you know, is skin cancers. But what's fascinating about that is people are worried about the skin cancers, but actually people who get outside, they may have more skin cancers, but they're actually not dying of it. So it's an interesting balance. So so basically, but I'm not advocating getting, for example, there's a recent article came out and about Decry talking about UV bed, living longer. Well, the answer is they get out in the sun a whole lot more.
Yeah.
Tanning beds
Exactly.
actually are outdoor. They want it. Why they do it? They want to look tan when they go outside on the beach.
Yeah.
It's a it's really not an explanation of the tanning beds. It's the behavior of getting outside. So there's that side of it. I think it's, limiting your exposure is good. The big problems with skin cancers and everything occur, and also eye problems. Blue, some parts of blue, sky blue, much more down in the violet blue, 425 of blue, can cause eye damage. Bright. Now you get that if you're in the Australian Alps and you're exposed to midday sun, but most of it, the safest time in the mornings, robust circadian clock. So that's really one of the big advantages.
Yes, I am out there sometime I try to get out for sunrise, but sometimes it's really early here.
And I don't mean literally at sunrise, because
Right.
you can actually shift your clock too early if you do
Yes.
that. If you're
Yes.
giving a big dose of light at a time of day that will shift you eastward towards
Yes.
Europe. But no, I'm saying is, you just in the first part of the morning,
Yeah.
before the sun has reached the sky.
Yeah. Yep. That's what I was referring to also. Like I go out to see the sunrise if it's manageable and it's not coming up at 5 o'clock in the morning. When those times were coming, I'm like, nope, I'm just going to get up get out there when I get up. But I try to get out there during that UVA rise if possible for at least a couple of minutes for sure. I want to make sure to ask you before we let you go about glasses and contacts and sunglasses. I get this question a lot. Like, what if I wear glasses or contacts or sunglasses? Is there any workaround for that? And am I getting any kind of the same signaling through the eyes?
Well, a number of parts of that, right? Sunglasses, the amount of light, and certainly that can help reduce glare and all. And if you're out in the mornings, I wouldn't recommend using sunglasses. You want to get the full benefit, like early morning. The lights, you can do that, be outside without seeing it. If we're talking about contact lenses or people get older, their lights change. They get corneal, because of their corneas and lenses in the eye, and they get their lenses. Then people sometimes offer blue blocking. Not a great idea, because you actually want to see the blue. You don't want to wear too much sunglasses. You don't want to wear a blue block. Certainly don't want to wear blue blocking glasses. That would circumvent, that actually prevent the benefit. Because blue is as beneficial.
Right.
It's all to do with it's not good or bad. So that would be certainly glasses in the evening using the block blue if you're in an environment with regular lights. So those are out there. But that's part of the thing. So and I think, it's also, before we finish, I wanted to, really talk just briefly, we could, about why this is. So it's 25 years since the discovery that light, that's 25. It's over 20 years since the World Health Organization recognized it. It's now, 10 years since we knew the answer of exactly which blue we had to control and built to solve it. And now, as our podcast goes out, it will be the 1-year anniversary of a census study. The answer, people say to me, Martin, it's your ideas, your view of the world, how well established, extremely well established. And to demonstrate that, I invited all the scientists in the world who've published the most papers, studies, participate in a census study. We had almost 250 of them told, and that group of scientists came to consensus. All these key things we've been talking about, that it is, in fact, light, that it causes increased light. They all concluded and agreed, in fact, the blue part of They came up with specific recommendations saying that light in the little blue is. They even said that the LED lights the stores today are blue rich, blue emitted lights, as most of them carry a warning label saying may be harmful if used it. And now I know a number of people around the world are putting in, a hazard. This is a hazard we're aware of.
Yep.
And that's a part of our healthy lighting worldwide now to try to get people aware of this. So yeah, and that's a year ago. And so this is well established. It's time to get on with it.
Right.
So that's my take home message.
Yes. And unfortunately, it seems like we're moving in the wrong direction with the lighting. As you said, the incandescents are banned and the blue light, the ones that have very high amounts are the LEDs are like all you can buy. But what are some workarounds for like night shift people or shift workers if, beyond trying to get the lights changed, if their employer's not cooperating or if that isn't a possibility? Are there some other workarounds for them to try to protect their circadian health and protect themselves from the blue rich environment that's artificial?
Well, I say always try to get the lights. Part of it, we've got that now in over 65, 40 changing as a result of it. So it works. It's got big effect, improvement in not only their sleep disorders, but also their errors. So basically, you've got to really understand, if this is going to reduce my sickness, it's going to make fewer errors in the workplace, perform better. Why wouldn't you want it? It's a relative to solve your problem. So basically, yes, you campaign for healthy that's light that's blue rich, zero blue. So yes, you have to do something about it. Well, can wear blue block. That can be a problem in the book. We tried doing that early on. In fact, our first solution we worked on, and we found that unfortunately take out. So you're working on a computer, color with the screen, right? You can't see certain.
Right.
That's not good. If you're running a control room or like that, or a
Right.
railroad, that's not a good thing. So much easier to change the lights. But basically, you can, sleep in the dark, of course, and try to keep it regular. Because the other real big lesson, regularity. It's much help sleeping. That's
okay. And it's circadianlight.org that people can find this information and find.
It's a resource site. It tells you where you can find that are circadian friendly. Tells you where you can find glass. It tells you it also signed up for a resource we're trying to keep. Now read my book. The book, The Light Doctor, is really the guide to this and give to a manager to prove this science is ready, available, the solution. I also write on Substack, a newsletter column, psychology. So those are, but
excellent.
Time has come. We got to get on.
Yes, I agree. I agree. It's like it's there. We got the resources and onward and upward. But The Light Doctor, perfect, is your book. I would encourage everybody to pick up a copy of that. And like you said, it's a great gift for those who have never heard of of any of this and have no idea really how harmful different lights at different times of the day can be. So I am fascinated by this topic, and I thank you for all your work and all of the discoveries that you've made along the way. And all the people listening to this podcast and beyond are benefiting from your work. So thank you for coming on today and sharing your knowledge.
It's a pleasure.